Hey everybody, Mrs. KJ here, going over 7.04, Review Hydrocarbons and Polymers. Review concepts presented in the lessons hydrocarbons and other organic chemicals and the lesson polymers. Carbons can bond with other elements and with itself. Its valence electrons, remember the outside electrons, allow it to make single, double, and triple covalent bonds, covalent meaning they are sharing electrons. This flexibility enables carbon compounds to have various structures such as long chains, branched chains, and rings. Small carbon compounds can even bond together to make long, straight chain and branch chain polymers. Polymers have many uses, such as in the plastics industry. Goals for this lesson, review the other two lessons. Alright, so again, there's a study guide if you would like it. Key concepts in hydrocarbons and other organic chemicals. Again, I suggest you copy-paste this, put in blanks, use it like a worksheet, and practice that way. Hydrocarbons are made primarily of hydrogen and carbon. There are many types of hydrocarbons. Alkanes have single carbon-carbon bonds. Alkenes have one or more carbon-carbon double bonds. Alkynes have one or more carbon-carbon triple bonds. Cyclic hydrocarbons have a carbon backbone geometrically shaped, so in other words, it's in a ring, only carbon-carbon single bonds. Aromatic hydrocarbons, one or more carbon rings made of alternating carbon-carbon single and carbon-carbon double bonds, and it has a flat shape. Double or triple carbon-carbon bonds affect physical and chemical properties. You can also have on a functional group, which can be organic, meaning made of what? Carbon, or inorganic, meaning made of anything else. And they define classes and chemistries of organic compounds. For example, you can have alcohols, which have an OH attached, and you can have alkyl halides, which would have one of the halogens from group 7A attached, such as chlorine, bromine, fluorine, or iodine. All right, so carbon compounds are also known as organic compounds. One type is called hydrocarbons. Carbon compounds, some contain only carbon and hydrogen, and they are called the hydrocarbons for hydrogen, carbon. Remember, anytime you see organic in chemistry, we're meaning that it's made of carbon. Key concepts in polymers. So polymers are made of monomers. Polymer types include copolymers or homopolymers. Polymers made from living things are biopolymers. Polymers make up many things, including plastics and fabrics. Polymers are large molecules composed of repeating units of smaller molecules called monomers, chemically bound together. The repeating unit may be made of one monomer, so it's a homopolymer, or different monomers, so it's a copolymer. Polymers may be straight chains or branched chains. A condensation reaction combines two monomers with the loss of a water molecule. So you have two monomers, there's a hydrogen on the end of one, an OH on the end of the other, they come together, the H and the OH pop off and make H2O or water, and then the two monomers are joined together. The next one says, in addition reactions, one monomer adds to the double bond of another to form a new single bond. So you have two monomers and the double bond opens up and it attaches to the next monomer, and when you put them together you get a polymer. Biopolymers are made from living substances. Alright, so they want you to organize in the map. So carbon compounds, some contain only carbon and hydrogen. What are those called? Pick your choice. They are hydrocarbons. Carbon compounds are also known as what? Make your choice. Organic compounds. Another type is called polymers, and hydrocarbons, look, they put it together. Many are polymers, and the types include, of course, copolymers. So go ahead and hit pause if you'd like, read through it, make sure that it all makes sense to you. And then we will go to the problems and solution book and go through those. Here's problem set 93, hydrocarbons and other organic chemicals. Objectives, draw structural formulas for organic compounds. Identify different types of organic compounds. Carbon atoms can form up to 4 bonds. This allows them to form a wide variety of chemicals, many of which are the basic compounds that make up living things. Almost every in your body and in the bodies of other living things is based on the element carbon. Most carbon-containing compounds are organic compounds. The most common kind of organic compound is the hydrocarbon. A hydrocarbon is an organic compound that consists of only carbon and hydrogen atoms. However, not all organic compounds are hydrocarbons. Some organic compounds contain oxygen, nitrogen, sulfur, and other elements in addition to carbon and hydrogen. Organic compounds are classified into different groups depending on how the atoms in them are arranged. For example, a hydrocarbon in which all the carbon-carbon bonds are single bonds is called an alkane. And remember, they can have different names, but they're always going to end in the ane. A hydrocarbon that contains one or more carbon-carbon double bonds is called an alkene. And again, it can have a different prefix like propene or butene or octene. Okay, so depending on how many carbons, but it always has that ene when you have a double bond. A hydrocarbon that contains one or more triple bonds is called an alkyne. Organic compounds that are not hydrocarbons are also named and grouped according to the arrangement of their atoms. For example, an alcohol is a hydrocarbon in which one of the hydrogen atoms has been replaced by a hydroxyl group, or in other words, there's an OH attached to it. Remember, organic compounds. A condensation formula shows the atoms in a molecule, but it does not show the structure of the molecule. Or sorry, not a condensation, a condensed. A condensed formula shows the atoms in a molecule, but it does not show the structure of a molecule. Many condensed formulas show the relative position of the carbon atoms in a molecule. This information can help you write a structural formula for the molecule. A structural formula, which is similar to a Lewis dot structure, shows the relative positions of all the atoms in the molecule, as well as the bonds between them. It does not show the molecule's actual three-dimensional shape. Most organic compounds are classified according to their functional group. A functional group is a group of atoms arranged in a specific way that give an organic compound a specific set of chemical properties. For example, the functional group in an alcohol is the hydroxyl group, and the functional group in a ketone is a carbonyl group, which is a double bonded oxygen atom. So depending what you add on, that's going to be the functional group, and that's going to help determine the properties. And the functional groups are on the document that I'm emailing out that you can use on all of Unit 7 quizzes or tests. Describe the formation of organic compounds. Carbon compounds are essential to the existence of living organisms. Which unique chemical properties of carbon make possible the great variety of organic compounds needed by living organisms? Go ahead and hit pause, get your answer. Recall relevant information. Carbon is a nonmetal. Carbon forms covalent bonds with itself and other nonmetals. Carbon, hydrogen, oxygen, and nitrogen are all nonmetals. Carbon can form 4 covalent bonds, and it can form single, double, and triple bonds. Reason. Covalent bonds between nonmetal atoms vary in strength and can be broken and changed during chemical reactions. The ability to form 4 bonds allows the formation of branching chains of atoms. Solve. Carbon compounds exist in greater variety than compounds of other elements because of the greater variety of bonding possibilities. Because each carbon atom can form 4 bonds, carbon compounds can have multiple branches and structures. The low strength of some covalent bonds allows biological processes to rearrange the atoms of carbon compounds to form new organic molecules. Example 2. Draw a structure formula for a hydrocarbon. So let's do some drawing. Drawing is big in organic chemistry because it helps you visualize what's going on. And because you can be branched and chained, and a lot of times it's just so many carbons, drawing them out actually helps with seeing properties as well. The condensed formula of the hydrocarbon methylbutane is CH3, CH, parentheses, CH3, CH2, CH3. Okay, so when you read that, you might be thinking, okay, what? So you have the first carbon, and it has 3 hydrogens on it. You have the next carbon, and it has the 1 hydrogen on it. And then it's got another carbon on it with 3 hydrogens. It's also attached to this one over here, which is a carbon with 2 hydrogens. And then at the end, this carbon has 1, 2, 3 hydrogens. The big thing with drawing is remember how many total bonds does everything get? Well, all carbons get 4, and hydrogens can only make how many bonds? 1. It consists of a chain of 4 carbons with a single carbon atom bonded to the second carbon atom in the chain. Each of the carbon-carbon and carbon-hydrogen bonds is a single bond. Draw the structural formula for methyl butane. So, each carbon atom will form 4 bonds. The problem states that the longest chain of carbon atoms in methyl butane is 4 atoms long, which you know because look, bute. Bute means 4. Start by drawing the longest carbon chain, then add the rest of the molecule. So, okay, so you're drawing this one, skip the one in parentheses, you're drawing this one and that one. So we draw our 4, and this one in parentheses is a CH3, which is a methyl group, and that's popped off the side of our second carbon. So it looks like this, and then you just add in a bunch of hydrogens. Specifically, you add in enough so that each carbon is making 4 bonds, so it should look like this. And note that the carbon-carbon bond between the second carbon in the chain and the single carbon branch is not actually longer than the other ones. Okay, so this is not actually longer, they just drew it longer so that you had enough space to write everything. So again, if you have this chemical, CH3, CH, parentheses, CH3, CH2, CH3, it's called methyl butane. The bute tells us that there's 4 carbons in a row. The ane tells us it's all single bonds. The methyl tells us that there's a CH3 branched off of it, and we know it's branched off of the second one because that's where it's written in here. And that's where it looks like. It's kind of cool. All right, draw a structural formula for a hydrocarbon with multiple bonds. The condensed formula for the hydrocarbon 2-hexene is CH3, CH, CH, CH2, parentheses 2, CH3. Okay, ene, what does that tell you? You know there's double bonds. Hex, what does that tell you? You got your 6 carbons. Okay. It consists of a chain of 6 carbon atoms with a double bond between the second and third carbon atoms. The other bonds in the molecule are single bonds. Draw the structural formula for 2-hexane. Each carbon atom will form 4 bonds. The problem states that the longest chain of carbon atoms is 2-hexane is 6 atoms long. Start by drawing the carbon chain, then adding the hydrogen atoms. So hit pause, see if you can do it. So we have our 6. We know our double bond was between our second and third carbons. And then you just add in the hydrogens, and that's it. And every single carbon needs 4 bonds. That's your key. Check the hydrogen, 1, 2, 3, 4. Check the carbon, 1, 2, 3, 4. Check this carbon, 1, 2, 3, 4. Check the carbon, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Learn to count in Spanish. 1, 2, 3, 4. All right, you get the point. Count to 4. Tip. Now we're going to go on to cyclic hydrocarbons. Cyclic hydrocarbons are hydrocarbons with a ring structure. The prefix cyclo in a compound's name indicates that the compound is a cyclic hydrocarbon. Benzene, ene, what does that tell you? That there are double bonds. Benzene is a cyclic hydrocarbon. It consists of a ring of 6 carbon atoms. Double bonds join the first and second, third and fourth, fifth and sixth carbon atoms. Draw the structural formula for benzene. When they're in the ring, you can just pick like the top one and start counting 1, 2, 3, 4, 5, 6. When they're in a chain, you always count from left to right. So, see if you can draw this one before I show you the answer. Hit pause. Each carbon atom will form 4 bonds. The structure consists of a ring of 6 carbon atoms. First, draw the ring, then add hydrogen atoms to give each carbon atom the correct number of bonds. And here you go. That's what it looks like. So again, they told you that the double bonds join the first and second. So like I said, just start at top and count around. 1, 2, 3, 4, 5, 6. And add in your hydrogens. That's it. All right, and we'll start this in the next video.